Okay, welcome back. So this is the last video for 8.2. And in this video we're going to look at the sequence of partial sums of an arithmetic sequence. Okay, so remember the sequence of partial sums is a sequence where you take the first n terms of the sequence that you have and you add them together, right? So like, for instance, S1 is just the first term of the sequence. Then S2 is you take the sum of the first two elements of the sequence. S3 is you add up the first three terms of the sequence, and so on, right? So the sequence of partial sums of an arithmetic sequence actually has a very predictable pattern, and I'll talk about the formula for it in a bit, but I do kind of want to explain where the formula comes from, at least with an example. I'm not going to derive the formula for the arbitrary for an arbitrary arithmetic sequence, but we will kind of look at it for a particular one and kind of see how it works with that. Okay, so let's suppose that we're dealing with a sequence here. We'll say that our a sub n is 2n plus 1. Okay, we'll say that this is our a sub n, and this is arithmetic because it's a linear function, right? It doesn't have any exponents on the end. It's kind of like an mx plus b form. Our standard form for it would look a little different, right? It would be like a 2 times n minus 1 and then plus some other number that's the first term of the sequence. So let's just kind of get an idea of what this looks like. A sub 1, when you plug in 1, you get 3, right? A sub 2, when you plug in 2, you get 5. When you plug in 3, you get 6 plus 1 is 7, right? And maybe just for good measure, we'll do 4. Okay, plug in 4, we get 8 plus 1 is 9. Okay, hopefully you can see that. All right, that's way down at the bottom of the screen. Okay, so this is kind of your sequence and it keeps going, right? So let's look at the sequence of partial sums of this guy. And let's try and find out what S sub n is for any n, okay? And we'll kind of look at here, we'll maybe start with one with a finite S sub n. So like, we'll maybe make it a big number though. Let's see, like S sub n, we'll maybe throw S sub 20, okay? So S sub 20 means that I'm going to be adding up the first 20 terms of my sequence, right? So all the way to A20. That's what that means, right? So what would this look like in with kind of a sum? So A1 we figured out was 3, A2 was 5, A3 was 7, right? And we keep going. I'm just going to do the dot dot dots all the way up to A20. Well, what would A20 be? When I plug in 20, I get 2 times 20 is 40, plus 1 is 41. Okay, so in this case, S sub n for this sequence that we're dealing with is, well, it's just we're adding up all those terms, right, up to the 20th term, right? So it would be the sum of all the odd numbers, essentially, from 3 to 41, okay? Well, I don't know that right off the top of my head, okay? That's kind of a big number. You could throw that in the calculator, but it would take a while, right? So there's kind of a trick for how you can do this. And essentially the idea is, I'm going to say S. We're going to say S. Well, maybe I'll say X because I want to find it. We'll call it X. How about that? We'll say X is equal to 3 plus 5 plus 7 plus all the way up to 41. I'll maybe add in one term lower as well. So we'd go down to, that would be like 39 would be the term before. Okay, 41. Okay, so this would be our sum here. I went down 2 because every time I'm going up 2, right? And so the one before it would be down 2 from the previous one, right? And so kind of the idea is with this, you can write X in a backwards order, right? You could add these up in a backwards order and it would be the same thing. This is kind of a really clever thing to do, is we're just going to write these backwards, okay? So 41, 39. The next term backwards, we'd go down another 2. So we'd be 37, and then all the way down to, well, 5 and then 3, right? I just wrote the sum in backwards order, okay? Now, it doesn't matter what order you add things up, so these two things will be the same. They're both X. Now, the trick here is if you add these two together just directly on top of each other, so you add these two together, these two together, these two together, all the way through. Okay. If you add those together, what do you get? Well, over here on this side, you have x plus x is 2x, right? And then when I start adding these together, I get 3 plus 41 is 44. Okay, 5 plus 39 is 44. 7 plus 37 is 44. Huh. Curious. That is very interesting. What do you think when we add those up like this? Even over here, 39 plus 5 is 44. And then 3 plus 41 is also 44. Sorry, there should be one more 44 there. Okay. So it's pretty crazy. When you add these in this way, you get the same thing for all of them. And they're all 44. How many 44s are there? Well, I added up 20 numbers, right, to begin with. There's 20 numbers here, 20 terms here, added to 20 terms here. So in total, 2 of each of them is making a 44. So there are 20 in total, right? There are 20 44s. So we get 2x equals 20 times 44. Okay, and then we just divide by 2 to figure out what x is, right? So it would be 20 times 44 divided by 2. Okay? And so, it turns out that for any arithmetic sequence, you can always do something like this to get the sequence of partial sums. Okay, so we'll kind of generalize this and write a formula for it now. I'm not going to prove the formula, but the reason for it is basically because you can do this sort of idea on it. Okay, so let me get another board here. Okay. Okay, so that leads to our main result here, that partial sums for an arithmetic, and again, arithmetic just means it's linear, right? Partial sums for an arithmetic sequence. Okay. What do they look like? Well, it turns out your S sub n, okay, you can write an equation for S sub n, basically using this idea that we just went over, is, well, you do n times, and you do a. So a is the same as what we used in our original like arithmetic standard form. So this is the first term, okay, and then plus a sub n divided by 2. Okay, so the dividing by 2 is happening because, like over here, to solve for x, we had to divide by 2. So let's see what happens when we use this formula on the example that we just did. Remember, the sequence we were dealing with was the sequence we were dealing with before was a sub n is 2n plus 1, right? So to find s sub 20, if I use this equation, essentially what it tells me is I replace everywhere there's an n with a 20. So it would be 20 times a plus a sub 20 divided by 2. Okay? And so when I figure out, well, what was A? A is the first term of the sequence. So the first term of my sequence was 3, right? When I plug in 1 here, 2 times 1 plus 1 is 3. Okay, so 3 plus a sub 20, I plug in 20 for n. So 20 times 2 is 40, plus 1 is 41. Okay, so again, we've got 20 times 44 divided by 2. Okay, which is the exact same thing I got over here, which is pretty awesome. Okay, so this is a formula you're going to need to know, is the sequence of partial sums for an arithmetic sequence will look like this. Okay, and if it helps you to remember what a is, you could maybe just put a 1 there to mean, well, that's the first term of your sequence. Okay. Cool. So let's look at an example. Well, we'll maybe do one more example. Well, we'll do 2 more examples of this to kind of get an idea for how this is useful. So let me get another board for us. Hopefully you're not getting bored because I've got another board here. Okay. So, for instance, one example you could run into is we'll kind of do the same, a similar sequence to the one we did before. Let's say that instead of them telling us we're dealing with a sub n is 2n plus 1, let's say they want us to evaluate this sum, 3 plus 5 plus 7 plus 9 plus, and then dot dot dot, all the way up to 201, okay? So first of all, we should note that this sequence is arithmetic, right? Because to get from these two numbers, we're adding 2, adding 2, adding 2, and so on, right? So this is arithmetic. And the equation for it is going to be, well, it's actually the same as this one because the first couple terms line up. But let's just practice. Let's say I didn't know it was the same as this one. How would we find the equation for just these numbers, okay, as like a sequence, okay? So the first term is 3, the second term is 5, and so on, right? So the first term being 3, that's going to be our A, so that's what goes over here. And remember, our formula is kind of D times n minus 1, and then plus the first term, right? So what is D in this case? It's the common difference, so it's 2. Okay, so this is a sub n, and you'll notice if you distribute in the 2 and simplify, you actually get the same thing as this. So it's the same thing. Okay, so this is our formula for a sub n, which is an arithmetic sequence. Okay, now we want to find a sum of these terms, right? But we don't know how many terms we need to add up, right? We know that we're going to stop here at 201, okay? But what is n when we reach 201 is what we really wonder, okay? So n here was 1, n here is 2, n here is 3, n is 4 here, and so on, right? But I don't know what is n going to be at the end here. I can't tell. And this is where we can use the equation that we just wrote to figure out what n is at this, what term 201 is in this sequence. So what we do is we just take our equation and set it equal to 201, and then we figure out what n is. Okay, so I'm going to subtract 3 from both sides, and we get 188. Okay, now we'll divide by 2, so we get n minus 1 is equal to 94, I believe. Then we just add 1, so we get n is 95. Okay, so that means that right here at that term there, we no longer have to wonder about it. It's actually n is 95 will give us 201. Okay, so what are we looking for? We're looking for the sequence of partial sums of a sub n when n is equal to 95. We want to add up 95 terms. So I'm doing s of 95. And now we can look at our formula, right? S sub n was given by this. So I plug in n. It's going to be 95. Well, what's a sub 1? It was 3, right? Our initial starting point. 3 plus a sub n, so a sub 95, okay, and then divided by 2. Okay, so I experienced some technical difficulties and the last bit of the video got messed up. So we were so close, I didn't want to redo the whole video again. But we had figured out that this was our a sub n, and we got to our formula for s sub n in terms of this. We figured out we were looking for s sub 95, and so we used this formula, which told us we had 95 times a sub 1 was 3, right, our first term, plus our last term, which was a sub 95, which is going to be here, right, the very last term of our sum, and then divided by 2. Okay, and so now we're just going to be doing s sub 95 is 95 times 204 divided by 2. So what is that going to be? 95 times 102, which I'd have to throw in the calculator. Let me do that real fast. 95 times 102. 9. Okay, so that's our number. Okay, so it turns out when you add up 3, 5, 7, 9 all the way up to 201, you just get this, right? And this is a much nicer way of computing it than actually doing 3 plus 5 plus 7 plus 9 plus, you'd be there all day typing numbers into your calculator. So that's why this is really powerful. I'm going to do one more example of this in the next video, and then that will be all. If you feel okay with this, you can go ahead and try the homework. I'll just do another example of this so that you can kind of get a little more familiar with it.